Hello, and welcome to the Deploying Decentralized AI Across Multi-Cloud Environments screencast. In this screencast, we are going to discuss how to build and operate a multi-cloud, multi-provider environment using OpenNebula to enable decentralized AI. Traditionally, AI workloads are trained and served from a centralized data centers. But as data becomes more sensitive, fragmented, and geographically distributed, that model starts to fall. Decentralized AI shifts intelligence closer to where the data is, at the edge, across clouds, or within the national borders. This approach offers some key advantages. It reduces unnecessary data movement, enables compliance with privacy and sovereignty regulations, improves performance through data locality, and it supports collaboration across organizations without the need to share the raw data. To make the decentralized AI a reality, you need the infrastructure that can operate across diverse environments, and that's exactly what OpenNebula provides. OpenNebula acts as a unified abstraction layer across edge, cloud, and on-premise resources. It allows you to manage your workloads as a single distributed system with a unified orchestration of virtual machines, containers, and Kubernetes clusters. Portability and elasticity so workloads can move or scale seamlessly. A compliance first model where each site retains full control over its own data and infrastructure. Native support for AI ready appliances, including Kubernetes stack like OneKey, GPU accelerated instances, and integrated storage and network. This makes OpenNebula a great platform for building secure and reliable decentralized AI systems. To demonstrate the decentralized AI in action, we'll be using the Vertora testbed, a production-grade federated infrastructure built entirely on OpenNebula. It spans multiple countries and providers across Europe, from cloud operators to research institutions, all contributing compute and storage while retaining full local control. This is exactly the type of real-world environment where decentralized AI thrives: multi-provider, multi-jurisdiction, privacy-sensitive. For this demo, we will deploy FedX, a federated learning appliance, across this testbed. Each site is going to run its own training jobs on the local datasets and only share model updates with the rest of the system. It's a perfect use case for decentralized, privacy-first AI collaboration. Now let's walk through the actual deployment we'll be showcasing based on the FedX appliance. FedX is a federated learning platform packaged as a virtual appliance in the OpenNebula. It allows organizations to collaboratively train AI models while keeping data fully local. Only model updates are exchanged and aggregated by a coordinator node. Here's what the deployment process looks like. We start by launching FedX. It's pre-integrated with everything you need: Kubernetes, traffic for routing, Longhorn for distributed storage, and monitoring with Prometheus and Grafana. Configure the infrastructure. We set up networking, assigning both public and VXLAN interfaces to support secure internal communication across multiple sites. We also define the roles for the control and client nodes. Scale out federated clients. Then we are going to deploy edge nodes in different regions, each running Docker and attached to its own dataset. These nodes operate autonomously, keeping control over the data while participating in the global training process. With everything in place, we launch the training job using FedEx Web Interface. We track performance live through Grafana and access Jupyter Lab directly in the cluster for hands-on experimentation and model refinement, all running locally without relying on external services. So we start by logging into the Vertora dashboard using our credentials. This is where we can manage all our cloud resources. Now let's go ahead and deploy FedEx appliance. We head over to Service Templates, and from the list, we pick FedX. Just a quick note here, this service is built on OneKey, OpenNebula's lightweight Kubernetes engine. It's super handy for spinning up clusters across distributed environments. We give our service a name, let's call it FedEx Gdańsk. We could tweak a bunch of parameters, but honestly, the defaults work just fine in most cases. That said, we'll enable traffic and Longhorn. Traffic handles routing and load balancing inside the cluster, and Longhorn gives us distributed storage, especially useful when you need a persistent volume across the nodes. We choose a public network for the external facing parts and private VXLAN network to connect the internal components. VXLAN is key here. It allows all the nodes to communicate as if they were on the same local network, even though they are spread across different data centers or countries. Once that's set, we hit next and that wraps up the FedX service configuration. While it's in process of deployment, let's break down the architecture a bit. Like any Kubernetes setup, we've got three roles here: a master, some workers, and a client role, this one specific to the FedEx setup. So the master runs in the Kubernetes cluster and manages services like RabbitMQ for messaging, PostgreSQL for data storage, Prometheus for metrics, and Grafana for monitoring and visualization. Then we have the clients. These are the Ubuntu VMs with Docker pre-installed. They handle computation and monitoring at the edge, as well as they are deployed in different data centers or even countries. That's the heart of the federated learning. The data stays local and only model updates are shared. Let's go ahead and scale the client to 4 instances. Each one becomes a learning node. Now that everything is up and running, we jump into the FedEx admin panel to manage the deployment. Here we can see the active federated clients, including Arsys in Spain, Ionos in Germany, and Gdansk TU in Poland, each represented as a distributed edge node. Then we take a look at the datasets contributed by each site, things like Spanish blog posts, German legal texts, and Polish newsletters. Each dataset remains local, respecting data sovereignty and privacy. We can also jump into Grafana to monitor the system. This gives us real-time insights into the CPU and memory usage for each client VM, making sure everything runs smoothly. Now we head to the FedEx web app to launch our federated training. Inside the training wizard, we select the AI model we want to use, tune some hyperparameters, and set up the fine-tuning process for distributed execution. We browse the federated datasets available across the network, each tied to its own original country or institution. We select the datasets we want for LLM fine-tuning, combining multiple languages and sources for multilingual training workflow. Once training starts, we move to the experiment monitoring dashboard. Here we can see the model's performance in real time, things like validation loss and accuracy plotted across training rounds. Each client contributes to the process while keeping its data local. To wrap things up, we access Jupyter Lab, hosted right inside a cluster. It's a powerful tool for data scientists to build, test, and adapt custom federated learning workflows interactively and without leaving the platform. This screencast is produced in the scope of ONEnextgen project. Thank you for watching and see you in the next screencast.